Today I am going to take a NCERT chapter motion. Okay, let's go for this question. So the monkey of mass 40 kg climbs on the rope where figure is given 5.20, which can stand a maximum tension. So this is an important point. So the maximum tension will be 250 Newton. Sorry, how much? 600 Newton. 600 Newton is given maximum tension. Okay. So the first case, in which of the following case will the rope break? First case, go for the first A. Even monkey climbing up the with acceleration 6 meter per second square. How monkey will go in upward direction? So must monkey will apply force on the rope T in the downward direction. So according to Newton's third law, this rod string will also provide the same force on monkey in the upward direction. So suppose that here you have, this is the monkey, okay, and so the same force T act in the upward direction, okay, and mg of the monkey will act in the downward direction. So they write the equation of motion for the monkey. So equation of motion for monkey, not for rope. Rope is not going anywhere. Equation of motion for monkey. So let's write here, where is going monkey? Monkey is going in upward direction. So T must be greater than mg. So the net force will be in upward direction, 10 minus mg, that equal to mass into acceleration. Acceleration they have given 6 meter per second square. So T will be here mg, m into g plus a. As you know, here mass is given 40 kg, g and a. So let's find out the, just take g equal to 10 plus 6, 16. 16 multiplied by 40, that will be the 640 Newton. So now this T is a greater than T max. So a string will break. So rope will, in this case, rope will break. Okay, because maximum tension of the string is given, can stand actually 600 Newton. Now the tension is coming 640, so the rope will break. Let's go for the B. So monkey is going to climb down with acceleration 4 meter per second square. So let's see. Monkey is going down. So now here which force will be? They have given acceleration is a 4. Okay, so here mg will be greater because monkey is going in downward direction. Because why 4 meter per second square? I am not going to change this tension concept. The point is, if monkey will not apply any force on the rope, then monkey will free fall with the g, like 10 meter per second square. But here they are coming down with the 4 meter per second square. It means monkey is applying some force on the rope to just decrease the speed, and that is a will downward direction. So now here you have to write monkey is a mg minus t, that equal to mass into acceleration. So now in this case t will be mg minus ma. So the m will be 40 and g minus a, like 10 minus 4, that is a 6, that is a 240 Newton. So in this case the tension is a less than T max. So a string will not break. Go for the question number 3. So monkey is going to climb up with uniform speed. Uniform speed, it means acceleration will be 0. So uniform speed. So in this case a equal to, as you know, dv by dt. So this will be 0. So in this case tension minus mg or mg minus tension, anything you can take, just equal to 0. So the tension will be m into g, 40 into 10, that will be the 400 Newton. So this T is a less than T max. So a string will not break. Go for the D. This is C and D. What they have given D? So fall down the rope nearly, no, the climb of the uniform speed, okay, done. Fall down the rope nearly freely under gravity. Okay, so now the acceleration is a g in downward direction. So just write here, simply going in the downward direction. So you have to write mg minus. So the mg minus t, that equal to mass into acceleration, and acceleration they have given m into g. So the tension equal to mg minus g, that equal to 0. So tension in the rope will be 0. So again in this case also, because this T is less than T max, so rope will not break. So only one case we have seen, that is a first case when the monkey is going in upward direction with 6 meter per second square. In that case only a string is going to break, because it is 6 meter. So only first case. So answer is only here one case, rope is going to break. Go for the question number 7th. So two body A and B of masses 5 kg and 10 kg in contact with each other rest on the table against a rigid wall. Okay. The coefficient of friction between the bodies and the table is a 0.1. Okay, so the mu is given 0.15. Force of 200 Newton is applied to the horizontal. Okay, so here they are given force 200, the A. What are the reaction of the partition? Okay, so what is the force between the A and B? Let's draw the free body diagram. So here this is the A you have, and this is the B you have. Okay, when 200 Newton will force apply, so the ground reaction force will be exactly, think first about the mu into mg. So just first you should calculate the maximum static friction force. So the maximum static frictional force, let's calculate this one. So this will be the mu into m into g, and I am going to combine actually. Suppose that both maximum force will act in the A and B in this direction here, because force is going to apply in this direction, so the friction force will act opposite to the applied force. So the mu into mg, if you calculate the mu mg, so mu here 0.15, mg you have to take the both, so the 5 plus 10, this into g you can take 9.8. So in this case mu mg will come 22.05 Newton. Let's, here you are going to apply 200 Newton. So how much normal reaction force act in this? So you have to write, suppose the normal reaction force is here acting, that is N. So just write the balance equation. So 200 Newton force in the right direction. What is the force acting in the left direction? That will be the normal reaction force plus frictional force. Okay, so the normal reaction force you have to find out, frictional force we know 22.05. So in this case normal reaction force will be 200 minus 22.05, that will be 177 minus 95 Newton. Okay, so this is normal reaction force from the rigid wall. But the question is, what are the reaction of the partition? Let's find the partition, because this, so now, so just draw the free body diagram. So here is a force acting, that is a 200 here, capital F, 200 force Newton, and B is here. In this way, on the direct on the B, 177.95 Newton is going to apply in this direction, and the friction force is going to act in the both direction, like here one and here also for both. Okay, and here first go for the find the friction force into the only 5 kg. Let's find out. So the friction force on 5 kg mass, that equal to mu 0.15 into 5 into 9.8. So if you multiply this, this will come 7.35. So the net force by the body A on B we have to find out. Suppose that here I am going to write here the force is in this direction, A is going to apply on B, that is how much? F on B. I am going to just write F on B. Okay, so just write the balance equation for A. Anyone you can select actually, either A or B, but you have to go for only one, A. So A total force is acting here 200 Newton in the right direction. Here A is applying on the B force, that you suppose that here FB, and the friction force only here, that is a value 7.35. So just write the balance equation. So the right direction you have force 200 Newton plus FB, that equal to 7.35. So what is the FB? So the FB equal to, so the FB equal to, you have to just write, find out 7.35 minus 200, that equal to minus 192.75. So minus is showing that this much force acting on A, okay, in this direction. So now you can write here force on B, force on, this is the force on A. So force on A is acting in this direction because here minus come out, okay. So the force on B, exactly same force act on the B, 192.65 Newton in the right direction, okay. So here we can take anyone, automatically it will come minus here. So minus is showing whatever force we have taken on A, that is wrong. So the force on A due to B will be in this direction, and according to Newton's third law or contact force, you just apply the equal and opposite force on the B. So here force on B equal to 1 due to on from through A, force on B from A, this equal to 192.65 Newton in right direction, okay. A block of mass 15 kg is placed on a long trolley. Of a static friction between the block and the trolley is 0.18. The trolley accelerated from the rest with a 0.5 meter per second square for 20 seconds and then move with uniform velocity. Okay, discuss the motion of the block as a view from the stationary observer on the ground. So suppose that this is you have trolley, and trolley is moving, is given is a 20 meter per second square. Sorry, not 20 meter per second square, given is a 0.5 meter per second square. So 0.5 meter per second square, and block is here, block is resting on the floor. Let's find out block will move or not, because that depend on the friction force. So let's calculate the friction force. So the maximum static friction force between the block and trolley, this will be the mu into n, n will be here mg. So mg will act, and this is a normal reaction force in the upward direction. So mu equal to m into g. Mu is given here 0.18 into mass is given, mass of the 15 kg, and you can take g equal to 9.8. So this will be, if you multiply this, 26.46 Newton you have. Another force will act, that is a mass into acceleration, that is in the left direction because trolley is going in the right. So the m into a, find out the m into a. So the m into a, that will be 15 into 0.5. So this will be 7.5 Newton. Then as you know the definition of a static friction force. So now this is the maximum static friction force, that is a 26.46 Newton. But how much friction force will act, that depend on the left hand side force. So now I am going to write down the free body diagram for the block of mass m. So here MA, that equal to 7.5 Newton, 7.5 Newton, okay. Force is acting in the left direction. Then friction force maximum you have 26.46, but now how much here required to just maintain the rest? Only 7.5. So that is a range of this, that is a reason I have written here maximum static frictional force. So friction force will be here exactly 7.5 Newton. So just make it rest. If you apply the force in this direction more than 7.5, then friction force also will increase. When? Till increase 26.46. If you apply more than 26.46, then friction force will be your kinetic then. That is slightly less than 26. But this is the maximum static friction force. And if you applied force is less than this maximum static friction force, then a friction force will be equal to the applied force. That we have discussed in our previous classes. Okay, so 7.5 Newton act in the right direction. So the mass will move with the trolley. Okay, first case is a observer. So trolley is moving and mass is in the rest, and observer here, that is outside. So observer will see trolley will also moving with the same acceleration. Sorry, so the mass is also moving with 0.5 meter per second square with respect to the ground. Okay, because there is no relative acceleration between the masses and trolley. So what trolley will look same, actually exact same mass will also look for the observer which is standing on the ground. Second case, they are asking about find the observer moving with the trolley. So suppose that here is observer you have. So now observer will also move with the 0.5 meter per second square. So the relative acceleration between the observer and the masses will be 0, because both moving in the trolley with the same acceleration. So in the second case, mass will appear in rest. Why? Because net acceleration, relative acceleration will be 0. Here will act 0.5 meter per second square, mass is moving with respect to the observer. This is the A and this is the B. Go for the question number 9. A rear side of the truck is open and the box 40 kg masses is placed 5 meter away from the open end as shown in the figure. See, this is the given 5 meter. So this is the 5 meter you have. The coefficient of friction between the box and the surface below is 0.15. So the mu is given here 0.15. On the straight road, the truck starts from the rest and accelerates with 2 meter per second square. At what distance from the starting point does the box fall off the truck? See. So the point is, I don't know why they have given 5 meter, but let's see. So the mass is 5 meter from the open end, sorry, this open end actually. Sorry. So they have given this one. This is a 5 meter. That is a point. This makes sense actually. So when truck will move with a 2 meter per second square in this direction, on the block, force will act mass into acceleration. Mass is given here 40 kg and acceleration is given 2 meter per second square. So this will be 80 Newton force will act in this direction. Let's find the friction force here. How much friction force will act? Mu into N, that is a mu into mg. So mu into mg equal to 0.15 into mass. Mass is given 40 kg. G you can take 9.8 or you can take 9.8, left 9.8. So this will be 58.8 Newton. Okay. So right side force is acting 80 Newton, left hand side force is acting 58.8. So the net force equal to, so the acceleration equal to, you can write net force divided by mass. So the net force equal to 80 minus 58.8 divided by mass is a 40, that equal to 0.53 meter per second square. Okay. So now we have acceleration. So you have to find at what distance from the starting point does the box fall off the truck. Let's find the time, how much time it will take with respect to the truck, not with respect to ground. First find the time actually. Okay, and time is independent of any observation here in this case, either truck or outside of the. So first find the time actually. So the S equal to ut plus half at square. So for fall on the ground, this the relative distance between the truck, box only has to cover 5 meter distance. So this will the 5 meter. Initially velocity equal to given 0 because initially was on the rest, and half acceleration is given here 0.53 into t square. So the time will be, if you calculate the time, so the time equal to 4.34 second. This much time will take to this will fall down here. But in this time truck will move. You have to find out what is the, because only block has moved 5 meter relative distance with respect to truck, but let's find the how much distance truck will travel. So the S equal to distance traveled by the truck, that is u into t plus half at square. Initial velocity of the truck is also given 0, half, but truck was moving with 2 meter per second square and the time is given 4.34 square. So that equal to 18.84 meter. So truck will cover distance truck will cover distance 18.84 meter with respect to ground. Okay, that is